Okay, so we've started this unit on trig and started it with a review of a couple of grade 11 topics. How to graph an angle on a coordinate grid, any size angle, positive or negative. Although we haven't really talked about negative angles yet. Okay. And we also talked about how to find reference angles for any angle on a coordinate grid. And we need to know those for the ultimate goal in this unit, which is to evaluate trig expressions. Like if I said the sine of 240, you'll be able to tell it to me. Or to solve trig equations. If I said find if sine theta is equal to √3/2, find me the possible measures of theta. Those are the ultimate goals. Today, we're going to look at a new type of angle measure. Okay? You guys are used to degrees. There is another type of angle measure that is used, and many times, many formulas in trig are given in this other angle measure formula. You can't use degrees. It's kind of like when, if you find a percent of a number, you never enter the percent in your calculator. You always change it to decimal. Okay? Kind of like that. Okay, so just sort of a review. Remember, we can draw an angle on a coordinate grid using the positive x-axis as the starting arm or the initial arm of the angle. And then depending on the angle we want to measure, the other arm, okay, or after we rotate it around the coordinate grid, that's the terminal arm. And then we measure from the initial arm to the terminal arm, okay? And we usually call that angle theta. Notice that we go counterclockwise, we rotate counterclockwise, we move the terminal arm counterclockwise when we want to find a positive angle. Okay? If we want to find a negative angle, and they do exist, we still use the starting arm as the positive x-axis. But then we go clockwise. And that will actually be a negative angle. So this is how the coordinate grid allows us to draw positive angles as well as draw negative angles. So if the rotation is counterclockwise, which you guys are used to, okay? The measure of the angle is going to be positive. But if we go in the other direction, it's going to be negative. And like the same rules still apply. Like if I said this, how much would you say that angle measure was? 90 degrees. But if I said this, what would you say the angle measure is? Negative 90. Where this is positive. So that's something to keep in mind, that we can do negative angles, which means that we can find the trig ratios of negative angles, which means that we could solve equations that involve negative angles if we wanted to. We won't go there. We're just going to use positive, but we'll get to that later. Anyway, here's the new angle of measure. Okay. Now, you guys are used to degrees. What can you tell me about degrees? Tell me something about degrees. Tell me something about how many degrees are in something. Yeah, the most common one that you guys know is that a circle is 360 degrees, right? Complete circle, complete revolution, okay? Which means 1 degrees would be very, very small. 90 degrees, you guys know, 180, you know, 270, you know. And then you can approximate other angles as well, okay? Now this new measure is called radians, okay? And how it works, angles can also be measured in radians. It's based on a circle, like degrees, except it's based on the radius of the circle. So here we have a circle, this is the center, which means this must be the radius. Which means this almost also must be the radius. Okay? So if we draw a radius here and a radius here, and we measure the arc length between those two, okay? So when this arc length is the same length as the radius, like if we took that arc length and stretched it straight, it would be the same as these. Okay? So when these are all equal, we have measured, or we have drawn 1 radian. Okay? So 1 radian is about this much of a circle. So when the arc of a circle has the same length as the radius, the measure of this of the center, or the angle from the center, is 1 radian. So 1 radian is about that length. Not exactly, because I don't know if this is exactly the same, but it's pretty close. Tell me, I'm going to ask you to think here, how many radians do you think there would be in a complete circle? You know there's 360 degrees in a complete circle. How many radians?
It looks like 6 on it.
6 and a bit?
Would fit.
6? That's a pretty good guess.
Is there 5?
Okay. 5 and something, maybe a little over 6. Okay. You're right. You guys are actually close. But here's how we can get it exactly. How do you find the circumference of a circle? What's the formula? 2 pi r. And how many r's are in 2 pi r? Well, we divide. How many radians are in 2 pi r? We divide this by this. There's 2 pi radians. Well, how much is pi? So 3.14 times 2 gives us about 6.28 radians in a complete circle. So you guys were close. It actually turns out to be just a little over 6. Okay? But usually we use pi to measure. So you guys have learned the first conversion from degrees to radians. A complete circle is 2 pi radians, which is 1 revolution. So if I said how much is 360 degrees in radians, you'd say 2 pi. Now we can use this to find other ones. How many radians would be in 180 degrees, or half a circle? 1 pi. Let's divide this by 2. Half a revolution. How many radians would be in 90 degrees? Pi over 2. Because I take the 180 and divide it by a half again. And that's a quarter of a circle, or a quarter of a revolution. What about 45? I have to take this and divide it in half again. Right, remember, when you divide by 2, that's the same as multiplying by a half. So pi over 2 times 1 over 2 actually gives us pi over 4, which is an eighth of a circle. So you now know 4 angles in radians and their equivalent measure in degrees. But we want to be able to convert everything, which we will do shortly. One note here, when you write an angle measure, how do you know if you're writing in degrees or radians? Well, if you don't put the degree symbol, then we assume that you're saying that it's radians. Okay? So without the degree symbol is assumed to be in radians. So if you want 60 degrees and you write 60, you just told me 60 radians. So the degree symbol is important if we want to do degrees. Okay. So given what I just said, which of these 3 is in degrees, which are in radians? A is degrees, B and C are radians. Okay? We want to sketch it. And notice that the first one's negative. So we're going to use a coordinate grid. Remember, the initial arm is always the positive x-axis. Well, you guys should know where to go at about 165 degrees. Where do you go for negative 165? I'm going to have to swing this way, right? How much have I measured now? 90. So how much more should you go? Is it going to be in here? But where? Close to 180? Closer to 180, right? So you're probably going to be somewhere around here. So this would be negative 165 degrees. This one's in radians. Well, I suppose what you could do is you could plug 3.14, the pi key, times by 5, divide by 6, get your answer as a decimal, and then you know where 1 radian is. So you could probably guesstimate where that would be. But let's try and do it without a calculator. Where would it go? First of all, it's positive, so we're going to go counterclockwise. Remember, you only know 4 radian measures right now. A full circle, a half circle, a quarter circle, and an eighth of a circle. Where would this be close to? Would it be close to a complete circle? Would it be close to half a circle? Remember, complete circle is 2 pi. Half a circle is 1 pi. Full? Why? How many sixths are in 1 pi? 6 of them, right? Remember, 6 pi over 6. 6 pi over 6 equals 1 pi. 2 pi would be 12 pi over 6. That's too big. Wouldn't it be a little bit less than half? Because 5 pi over 6 is a little bit less than 6 pi over 6, which means this is half a circle. We should be a little less than half a circle. And that's 5 pi over 6. The last one. 1.2. Well, there's our initial arm. It's positive, so we're going to go counterclockwise. How much do we go? Well, you guys remember, there's 2 pi in a complete circle, which is about 6.28. So 1.2, would it be in this quadrant, this one, or this one? We're a little over 1 radian. I showed you what 1 radian looked like before. We'd be in quadrant 1. 1 radian would probably be close to the middle. So we'll go a little bit higher. Remember, we're just estimating. It would be around there. We don't have to be perfect, but we do have to be in the ballpark. So how do I convert any angle from radians to degrees? Or sorry, from degrees to radians? Well, remember, 180 degrees is equal to pi radians. So if I divide both of these by 180, that's going to tell me how much 1 degree is. And 1 degree is pi over 180. So if you want to convert any degrees, you just multiply by pi over 180. So if I said 30 degrees, we're going to do it 2 ways. We're going to express it in terms of pi, so we're going to have pi in our answer, or we're going to get a decimal approximate. So how do I convert 30 degrees? Well, I just do 30 times pi over 180 equals 30 pi over 180. But that's not reduced. I can reduce the numbers. What could I divide? What's the biggest number I could divide the top and bottom by? 30. So if I divide this by 30, I get 1. If I divide this by 30, I get 6. So the simplified answer, 30 degrees, is pi over 6. And how do we go to approximate decimal? Well, we just on our calculator, just divide the pi key by 6 and round it to 2 decimal places. And if you do that, you should get approximately 0.52. So slightly over half a radian. Which kind of makes sense because 30 degrees is less than half in quadrant 1. So that makes sense. Yeah. No, sometimes it may be 3, sometimes it could be 1. I just asked for 2 this. Yeah. So we should be able to do these ones now. So this is 120 times pi over 180, which is 120 pi over 180, but I need to reduce it. Highest number that divides into 120 and 180. 60. 120 divided 60 is 2. 180 divided 60 is 3. So we get 2 pi over 3. And then if I want to go approximate decimal, I just punch this in 2 times the pi key, divide 3 on my calculator, round it to 2 decimal places. This time I'm going to get about 2.09. Which makes sense because 120 is in the second quadrant if you measure it on a coordinate grid. And over 2 radians goes into the second quadrant. This would be the same thing, so we get 250 pi over 360, which will be able to be reduced because they both end in zeros. What do you think about this one? What do I reduce it by? What's the highest number that goes into both of them? 10. So this gives me 25. This gives me 36. So the best I can do is 25 pi over 36. 25 pi over 36.
It's supposed to be 1/8. Yeah.
Oh, yeah. What am I doing? Thank you.
I was like, what am I doing?
I'm not quite sure why I did that. Let's try that again. So we can divide them both by 10 and we get 25 over 18. So it's 25 pi over 18. Which, if I punch into my calculator, round it to 2 decimal places, I'm going to get approximately 4.36. Negative 300. Don't forget the negative here. So negative 300 times pi over 180 equals negative 300 pi over 180. How about that one? Well, definitely 10, definitely 20. 60 would be the highest. So that gives me 5. That gives me 3. So it's negative 5 pi over 3. Don't forget to keep that negative going. And then negative 5 pi over 3 on your calculator would give you approximately negative 5.24. It's just getting close to a full circle in the negative direction. Clockwise. And then finally 270. 270 times pi over 180 gives me obviously 270 pi over 180. About that one. $90. Well done. That gives me 3. That gives me 2. So it's going to give me 3 pi over 2. That's one you're going to remember. Trust me, you will. And then 3 pi over 2 is equal to approximately 4.75. That's 3/4 of a circle, because 270 degrees is 3/4 of a circle. Okay. So that's how we go from degrees to radians. Times by 180. So if we times by 180 to go from degrees to radians, how do we go back? Divide by pi over 180. Okay. But we remember, we don't divide fractions, we always change them to multiplication. So dividing pi over 180, converting to multiplying means multiplying by the reciprocal, 180 over pi. So now we're going back the other way. So we're going to take each one and we're going to times 180 over pi. And this is going to give me 180 pi over 4 pi. Well, the pi's cancel each other out. What can I reduce 180 to 4 down to? Or can I actually divide it exactly? Yeah. And I'm going to get 45 degrees. That's an exact value. It's exactly 45 degrees. Okay. 3 pi over 5. Notice when we go from radians to degrees, the pi's will always cancel each other out. So this is going to give me 540 pi over 5 pi. Yoink. And 540 divided by 5. And you do it in your head, you'll get 108 degrees. Right? Because 500 divided 5 is 100, 40 divided 5 is 8. 108. We used to do more of that stuff back in the day. When you guys could do those things in your head. If I said 25 squared, you'd be able to tell me right now, like your multiplication tables. No, nobody got this. What's that? 25 squared. Pi? Somebody said pi? Yeah, it's pi. Good try. No, 25 squared? 625. 14 squared. Look at you. Look at you. 21 squared. Okay. If you need a minute, take a minute. This one, notice the angle in radians is not given in terms of pi. So 1.8 times 180 is going to give me 324 over pi. Is that 441?
Yeah.
Okay. And this one we got to do on our calculator. It's not going to give us an exact answer, so we got to round it up. So when we do that, we're going to get approximately 103.13 degrees. That was when I was at SJR, when you came out of grade 6. You had to know your multiplication tables from 1 to 12. You had to know your perfect squares from 1 to 25 squared. You had to know how to do all operations with fractions and all operations with decimals. By the end of grade 6.
I was at a public school, so I was probably kind of.
Now, you don't know until the end of grade 8, at least.
Or 12.
Okay, this one?
Probably 16. Probably 5.
Come on, you guys, 5 times 180. No problem. What's 2 times 180? 360. Now hang on. Now double it. Because that double it will be 4 times 180.
420.
No, 360 doubled.
Oh.
720. But wait. We still have to add another 180. Because I did 4 times. It's 5 times. 900. Sorry.
Something funny.
What's negative 900, or what's 900 divided by 6? That's a tough one. Without a calculator.
150.
Negative 100.
Not you. That's smart.
Whoa. Whoa, whoa, hey, 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 whoa, hey, hey, whoa, hey, whoa, whoa, whoa. Don't look at her. Hey, look at me. Hey, whoa.
Down, girl.
Yes, sorry. You got a different answer. No, maybe I am incorrect. Did you do 3.14 or did you do the pi key? Yes, you do. Look at you. I can literally see your pants on fire. You are just lying so badly.